One fan is on first, the second fan stays off. So that makes more efficient unit because it only uses like 25, 28 watts. Compare when a two fan running on the lower speed, it uses 45 watts. So about the half of the power, but it also doesn't need to kick in all the time, because if the two running and the temperature cooling outside, that they constantly turning on and off, or if you use in your sprayer, or like I did the sprayer, I did modification and I put those foggy misters, whatever it is, it's just to use less water, a little bit less water, but also it spray all over the place and cool down the air around, makes this unit run a lot less. But what's cool about it, you don't use so much power, and also you don't have that kicking noise when the second fan, not that often. It still will kick on the second fan, but at least it's not as often as when you run all the time two fans and the two needs to kick in, so you have more of that noise coming out. So hopefully it will help someone to reduce that noise when you run only one. So right now it's kind of cooler with those misters, so it's not even kicking the second fan on. It only uses one fan to cool down the unit, so which is pretty cool and efficient. Every time it kicks in, it's actually used a little bit more power. It's almost like kicks to the 700 watts and then drops back to 40 watts when you use two fan option. So I'll show you how to do it. Stay tuned for this video and let's get to it. So in order to do this modification, we need to remove these 4 screws. Now I was not able to find this 2.5, looks like it's 2.5 millimeters. I actually have it, but it's a little bit loose, and I stripped one of that screw a little bit here, so I have to, but I'm gonna be actually doing the first fan here, adjusting. I'm gonna keep that one running because the fluid, I believe, runs all the way from intake, comes around and goes back in. So we'll be cooling the furthest way. It's probably better to use this one first, I'm not sure, but we'll see. All we have to remove this 4 screws to get to this kind of brake board. It's basically this was very quiet, actually start up. So once in a while it's super quiet, no problem at all, but it will start sometimes super loud. All right, so it stopped, so it should start running the fan pretty soon once the coolant gonna warm up to the point where it's gonna kick the fan in. So let's see if that this time we will get this noise. Sometimes you have to wait like 30 seconds, but it would really be annoying if you have every 30 seconds kicking the fan. All right, I hope you guys heard this noise. So that's how it annoying sometimes comes in, and if it's in the middle of night, every minute you kick this sound, that just kind of annoying. It's echoing into the window, especially when I keep my door open for night cool. Anyways, that's the point here, to get this, to limit this noise by having only one fan turning on and off versus 2 fans all the time, and also potentially minimize the time when it kicks in and out. So let's get to it. Let's see how we can adjust it by doing one fan running less time. All right, so it will be just one fan running. The second will turn on after about first fan reaches 20%, I would say. See, it started this time okay, so maybe 1 or 3 times it would start okay, and then it will kick with that sound. So you would hear that almost every minute. So you could see within the last 2 minutes it started twice, so it's not that bad, but it's still very annoying. You could hear the sound like 30 times an hour, which It's pretty crazy. Okay, if it's next to your house or next to your windows, where the AC units are usually, but these units are like constantly running, there's no issue. So the only issue is when it kicks in the sound. Like when it's running, super quiet. Look at that. Can't even hear my AC units a lot louder, mini splits, than this fan. This fan is super quiet. All right, so first step, I need to make those resistors, and I have basically purchased the kit that have a bunch of different ones, but I already figured that 200K is the one to start. So really I only have 100K kilo ohms, so I need to create 200. I already did one and install, so now I'm gonna do 240. So I use 100 and 147, 200s and 147, and we're gonna connect this in series. Basically, I'm gonna twist these two legs. There's no negative, positive. You can twist any way you want. One side, and between them, it's gonna be, if you put 200s together, you're gonna get 200 ohms. And this is 1 watt version of these resistors. You don't need any powerful resistor. Then I connect 2 other legs and twist it same way. So now I have 3 resistors in series connection. So now just gonna twist it really well. You can solder this wherever way you like. I don't think it's really matter. It's just as long as you have a good connection there. And those ends, I'm just gonna, you can clip them so they're not on the way, or just gonna bend it away. And I'm gonna tape it just like that. So, and I put it 300 for this one. This one is gonna be 240 kilo ohms. So let's test it out, make sure it works. So I'm gonna put for 220 mega ohms, because 200 kilo ohms not gonna read it. It's gonna be out of maximum. And let's test my 247 first, make sure it's correct. So what are we getting there? 200, yeah, 0.24 mega ohm. That's 240 kilo ohms. This should be 300 kilo ohms, so 0.3 mega ohms. Is it 0.3? Yes, exactly 0.3. So we have 300 kilo ohms, and this is 247. So let me rub this and label. Just gonna rub, so it's basically, I don't have any accidental connection here, just like that. And I'm gonna use only 2 legs. So now let's open the fan, and I'll show you guys what I did there. So I'm gonna test now on this 247 next, because I did 200 kilo ohms, works fine. It delays the fan by roughly, by when the first one goes to 20% or something like that, then the second kicks in. I want to just make sure when it goes to 30%, I think it's where I want the fan kick in, so I don't have that second fan turn up too often. Okay, so let's try this one first, 247. Let's see how it works, if it's gonna even work at all or not. So let's go check it out. All right, so I'm here at my fan, the left side that I'm gonna modify the delay for fan to kick in. So I'm gonna open these 4 screws. It's basically 2.5 millimeters, I believe, but I'm using the star here to open. I picked the wrong one. Yeah, so I'm using the star T10. I tried T9, didn't work. So T10, I'm gonna unscrew all these 4 screws carefully, and I suggest you turn off your fan, because there is a high power 240 volts coming. I'll show you where it is, and so you don't get any shortage or anything like that. So right there we have this screws carefully set. So here is your high voltage side. This is 240 just right here, neutral and load. Now, did you see what I did? I already have this connected this 200 ohms right there between these 2 devices. So what I did, basically, I disconnect the 0 to 10 volt so this cable right here, see right there, it's a 0 to 10. It went to this connector right here. Hope you guys could see it. And basically what happens is you can read the voltage if you set to the voltages when the fan gets kicked in. If you measure between two of these, when the fan start to get on, you will get the voltage reading basically about 2. Let's measure here. All right, so I got my it's kind of difficult to measure this at the same time, so let's take a look at the voltages here. So I got my sprayer off, so it should increase the temperature quicker and increase the voltage here. That's how the controller works. Basically, once the thermal sensor gets higher temperature reading, it adjusts the voltage here from that control board of the air. See, it's 0.09. So I think at 1 volt, it's where the fan starts spinning. And at the actual wire here, we are reading 1.2 volt. Okay, so it's 2 volts already. So our first fan right here is already at 20%, but this fan just started. Okay, just started right now. So let's see. Yeah, 1 volt exactly. It's 10%. So that's how it gets controlled. So we get 1 volt, 1.1, 1 volt until it drops below 1 volt. It will basically spin, and we are at 2.4 volts now in the system. So now if I'm going to disconnect this, and instead of 200 kilo ohms, I'm gonna drop. So we're working on the low voltage side. That's why I'm kind of like, but don't do that under voltages, because there is a high voltage side there. There's 240 volts. So have to be carefully disconnecting the power in order to properly work. So see, if I disconnect this wire, I don't have any spinning on this fan, gonna stop. So now I'm gonna test 247 ohms. That's my next test. All right, so let's see how much voltage we are dropping if we're going from 200 kilo ohms to 247 kilo ohms. Let's check the voltage. All right, so let's see where we at the actual. All right, so we are already at 2.5 volts. Okay, so fan just started at for some reason dropped 2.7 volts, so it's almost at 30%. That's where we got this kicked in. So I'm gonna try actually 300 kilo ohms next, because I want to be at 30%. I want the first fan reaches 30 and then the second kick in, so this way it doesn't actually kick at night maybe at all. We'll see how it works. Will be pretty good test for tonight, because when it's cooler you don't actually need to run 2 fans. You maybe just need 1 fan should be enough. And let's see, let's connect 300 kilo ohm and let's measure our voltages here. So now I'm gonna show you here what are we reading at 0 to 10. So we are at 0.8 volts, 0.9 volts. All right, so temperature increasing 0.9. Let's see if we are 2.7 volts at the main controller, 2.8. So going close to, okay, 2.9. So wonder once we get to 3, okay, so we almost reaches 3. So that the seconds, the 30% speed probably on the first one, and that's where we got kicked in. So I'm not sure if I reach at 30% really there yet. My guess is probably not, but if it did it, it's actually worked pretty well, because now I'm pretty much where I want it to be, because I wanted like the first fan ran to 30% and then the second kick in. This way at night, this probably goes to 30%. It will be sufficient to cool down this whole unit. Let's see where we at now. Let's do one more test. It's kind of hard to hold this meter with that. Right, so at the controller we are 2.7 volts. Maybe we're not exactly 30%, maybe it's still 20% fan speed. 2.9. See, it will kick in after 3, almost 3. So it doesn't really reach. See how noisy it kicks when it kicks in. So it doesn't really go. So I wanted actually to go to 30% first, and hopefully 30% will sufficiently cool down before the second fan will turn on. So let me think here for a second. Let's do this math, and I think I probably just need to go to 347 kilo ohm to reach that, because see, like it just turns in and turn off. That's what happening at night. But hopefully at night when it's not as hot, it will completely eliminate the sound. But during the day it will kick in, kick out, but that's fine because it's not as crazy. During the day there is a lot more noises and it's not really critical. So let me go and make the 347 to do this test again, and I'll come back just a second. All right, so I have made the 347 kilo ohm resistor, so let's check it out and make sure it's correct. Should be 3.034035. Yeah, that's correct, because it's roughly 347, so it's rounding up to 3.34 mega ohm. That's a 340. I would call 347 kilo ohm. So now we are ready to replace it and hopefully get rid of that sound at night. So we will hopefully go to 30% on the first fan over here. So right now it's at 20%. I could hear that's a little bit going a little slightly louder, but it's still like super quiet. You can hear how quiet it is. So let's put 347 kilo ohm, fit it pretty nicely, and let's measure how far we're gonna go with this voltage. Let's check what's the voltage drop first of all. Okay, so we are at 0.93 volts, so getting pretty close. 0.95, so it will kick at 1 volt. So we are just getting there at 98. All right, so it's actually at 99, almost 98, 99. That's where the fan just kicked in. And let's measure where we at from the board. Actually, what's the voltages from the volt? 3.3 volts. So that's perfect. That's actually where we probably wants to be at, to the maximum. Actually, I'm thinking now, because at 0.9 it turns in. See how it drop in with the second fan, but it's still running, the second fan running 30%, and then dropping, the temperature start dropping, so it goes, the voltage goes down a bit. So we're not gonna get back in until we get to back to 99. So that's pretty cool. I think that's what I'm gonna leave it on for this test. There may be another nice way to do it, but I haven't figured out yet. So I'm gonna just test this way, and I'm gonna rub just with tape so I don't touch any electrical parts in this controller or connector box. Pretty much all it is. There's no parts in this, it's only connector connections to all this craziness. So I'm gonna try to fit this and then have this wire there on the side right here, the extra wires, so be extra careful. There is a high voltage right there. Okay, and I'm gonna cover back with this cover plate. All right, nicely and nice and tight. There's a rubber gasket actually around, so that's pretty neat. So no water should get into this box right there. Just want to make sure it can be tied in, and these connectors are not on the way. So all I did just these little extensions here and connected back to this nut. The trick is to pull this wire actually out. You have to press in the board below and release this wire, so that's kind of tricky part. Kind of skip this. All right, so let's see if it's gonna fit this way, the way I want it, tight and nicely. Okay, it's a little pressure, but I think it fitted nicely back in. Okay, you may want to use different type of connectors if you try. Okay, need to put the camera here on the side. So now you could see that fan is working. This fan completely off until it reaches, the second reaches about 30% and slightly higher. Then this fan gonna kick in and help to cool down the fluid. Now, how it will affect the temperature of the fluid, I think it will be, you're gonna see about 1 or 2 degree temperature higher. So there is another way how you can keep your there's another way how to lower the temperature by using the same type resistors, but different resistors. Here it's about 50 ohms I use in here right now, 53 ohms in parallel, not in series, in order to warm up the unit. Actually, I'm warming up for my KS5L. So now you could see this fan kicked in. It will cool down the fluid and it will stop spinning, and this fan will continue to spin. So let's give it a minute here when we are cooling down, and take a look right there. So this fan totally gonna be off, and if I turn my sprayers on right now during the day when it's warmer, I think this fan never gonna even kick in. And so I hoping that for at night I will have this solution, so at night I will not have the issue that the second fan will kick in. Maybe on the first one, if it will turn off, it will kick in when it's super cold. But let's see. Let me turn the sprayer, and hopefully it will cool down enough that it's not gonna, look at that. Look at that sound, you know? Yeah, so during the night, not very nice. Okay, so I have my sprayers on. So hopefully with the spray on, this second fan never have to turn up even during the day. So we'll see how it works. I'll let it run for maybe another 20-30 minutes. We'll see. And I hope this fan is gonna reduce the speed pretty soon because of the how much cooler the air when you turn those sprinklers up. You know, when you turn that sprayer, it's actually cooling down so much quicker. I could see already this fan probably went to 20% from 30%. So that's super cool. That means this one never gonna even kick in. I only using one fan, and it's enough. It's a power consumption level, noise level, much lower. Obviously, when it's gonna be 100 degree, I'm wondering how is this fan will be helping enough or not. I'm just want to make sure. So it's not completely done test. So, but if anyone kind of figuring this up. Maybe it will help you to process this thing, but that's where I'm at. Not recommending doing that. It's just one way to make this thing work in a little more efficient way, and especially for me it's the quieter way, for I don't have that second fan keep on kicking. Obviously if you have two fans running, they're both gonna kick in and stop, kick in and stop, which is actually even louder, because sometimes two of them will make a loud noise and it's like echoing, and when it's one make a loud noise and the second not, it's not as loud, but it is, you've heard it, it's kind of like loud sometimes, like a shot or something. Anyways, that's it for this video, guys. I hope you liked it, and be careful when you open this stuff. Again, it's 240 volts, constantly comes there, so if you don't disconnect the power, you're under 240 volts, so you can shorten and damage your device. I would recommend disconnecting for sure, and make all the safety procedure I was just showing you in this video, so I can show you the voltage in the real time. So that's that fan not kicking in. All right, with the sprayers we actually did it, so it will be only one fan, super quiet, actually almost going to 10% now. It will be between 10 and 20%, totally fine, up to 40 watts. We can go and check how much watt we're pulling actually in our shed. Let's check it out. Yeah, so we are pulling 25 watts out of the wall for this fan at 228 volts. Yeah, only 29.6, so take a look. All right, so it's beautiful morning, and it was a beautiful night because I didn't hear that fan starting at all. The birds are happy. So basically is one fan running, it goes from probably 10 to 20% up, doesn't reach maybe 30%, and that fan doesn't even kick in because at nights are cooler and it's enough just to run one fan. So if you're running more machines, I have 4 currently in C6 tank, but I guess if I run all 6, it will probably create more heat, or depending on your ASICs, you may create more heat, so you may need to do different resistors and play with that, how depending where your stage when it's switching and to the completely off the fans. But if you separate, one will kind of always run, and but it's fine because it's running on a very low power consumption, like 23-25 watts, right? And maybe up to 28, and it goes to 20% where it's like around maybe 35 watts. So it's not big deal, because if the 2 fans kicks in, it's more wattage, and they always kicks in, not always, but mainly when it's making the noise, kicks to the full speed, almost to 700 watts peaks. So it kind of peaks out and then goes down. So I don't think it's really good for the fan motors, but at the same time it solved the problem that I have. Maybe somebody having the same issue with the nights creating that noise on the fans, and maybe help somebody to figure this out. Anyways, thanks for watching. We'll see you on the next one.